Okay, hi folks. This is my first instructional video. It's going to be on polar coordinates. I know we've done this prior to the break, and the idea is I'm going to try to review some of the material because I'm sure that over the recess we've gotten a little bit rusty. Okay, so let's start with conversions, and here we go. All right, example number one. I'm probably going to be making short videos. So I'll do a couple examples on conversion. All right, first one is convert x, y is -1 comma negative radical 3 into polar coordinates. So I think the way to go with this is going to make a coordinate system diagram, and -1, -3 would put this, negative radical 3 rather, would put this in quadrant number 3. So, okay, so x is -1. Y is negative radical 3, and Pythagorean theorem would make this a 2, and therefore what we have here is one of our special right triangles. So we're supposed to know in 30, 60, 90, the side opposite the 30 is half the hypotenuse, so this would be a 30, this would be a 60, okay? So therefore we can just look at this and instantly R, of course, is a 2. R is the distance we're going out on the radial line. So this is pretty much by observation. Okay, and if you didn't quite get that, what you could have done, of course, is use this formula here. So let's give that a try, right? R equals the x value squared plus the y value squared, all, summed in order of a square root. So this is 1, this is 3, so it's radical 4. So R is clearly a 2. Okay, and then by recognizing the special right triangle, we know the reference angle is 60. So therefore, the actual angle here is 180 plus 60, or 240. Okay, so theta would be 240 degrees. And if for some reason the question asks for this in radians, then, 60 is pi over 3, right? So this is 4 times 60, so it'll be 4 pi over 3 radians. And putting it all together in polar form, r comma theta would be 2 comma 240 degrees. One answer, of course, in degrees. Alternate answer would be 2 comma 4 pi over 3 if you're doing it in radians. And both are correct. It simply depends on which one you use based on the wording in the problem. Okay, just a word of caution in that we agree, standard polar form, that r is going to be non-negative, right? Greater than or equal to 0, and theta is going to be between 0 and 2 pi. But as we're going to see later on, what will often happen is we might have alternate forms. So if you realize that, what you could have done, go away, guy. All right, let me fix that up. All right, so what we could have done is we could have reflected this and made r of -2, and then you have an angle here of 60. So that would be an alternate form. So an alternate form of this here would be -2 with r and 60 degrees as the angle. So there are an infinite number, really, of different representations for the same polar point. But we're going to stick with the standard form, and we'll talk more about that later with the use of graphing. Okay, so this is example 1. Example 2 will be in the next video. I'm going to keep these short, and that will be slightly more complicated problem with a twist. Okay?